Hi everybody, I want you to meet my new friend here at the Perimeter Institute, Robo-Thespian. Robo-Thespian is a pretty solid math whiz, which is good because I'm not great at math and I need his help right now. So can you give me a little hello? Can you give me a little help right now on something? I've been known to write a few books in my time, and I've got a couple of kids who are going for post-secondary education right now, and I may need to make as much as $20,000 in order to help pay for their education. Now, if I make 10 cents a book, how many books am I going to have to sell, Robo-Thespian, in order to realize $20,000 for their tuition?
200,000 books. Steve, better get your bottom in the chair and start writing.
I had better get my bottom in the chair and start writing. Okay, thank you for that. That was very helpful. You see, I don't really have to know math at all, do I? Ha ha ha. Thanks to Morgan Rowe of Engineered Arts for Robo-Thespian's participation in tonight's program. I got a feeling my job's in trouble after having seen that. Anyway, it's not too far-fetched to imagine a world where robots do our math for us. We are sort of already there. Those robots are called calculators or smartphones. And so for students who don't excel at math, it's easy to say, why bother learning math or science at all? Thanks for joining us, everybody. This is night 3 at the Perimeter Institute in Waterloo, Ontario. Tonight, the program is it's about more than just making change for a 20. It's about understanding and appreciating the basic whys and wherefores of maths and science that have shaped the world that we inhabit. How do we teach an appreciation of science to those who are fearful of it? And joining us now to help dissect what can be done to help us figure this out, here are Lucy Hawking. She is the co-author with her father, Stephen Hawking, of George and the Big Bang. She comes to us from London, UK. Sanjoy Mahajan. He is Associate Professor of Applied Science and Engineering at Olin College in Needham, Massachusetts. Andy Chandler Grevitt. He is Teaching and Research Fellow at the University of Sussex School of Education, also in England. Ian Vandenberg, Director at the Center for Education in Mathematics and Computing at the University of Waterloo. And finally, our host, Neil Turek, the Director of the Perimeter Institute and the author most recently of The Universe Within, From Quantum to Cosmos, and as we have done every night from the Perimeter Institute, can I ask our audience to welcome our guests from near and far to this evening's program. Just before we start with questions, we do want to remind everybody watching us at home that if you couldn't make it to Waterloo this evening, we do have ways for you to get engaged and participate in our program. We've got a special website that has been live streaming all of our programming. It's tvo.org/learning2030. Our producers are standing by there right now as well to participate in live chats. You can go via Twitter using the hashtag learning2030 or the hashtag EQX13 for Equinox 2013. So once again, tvo.org/learning2030, or of course our regular website as well, theagenda.tvo.org. Okay, Lucy, let me start with you, because when we think of science, we think of something very specific, very exact, very rigorous, and yet in your talk earlier today, and in much of what you talk about, you tell us that science is actually first and foremost about imagination. That doesn't compute for a lot of people. So help us understand what you mean when you say that.
Well, the talk I gave today was about imagination and the part that imagination plays in the scientific process. And so I talked to some scientists working today about how they use imagination. And there were some great answers from them. Fabiola Gianotti from the Large Hadron Collider said, imagination is the fuel of science. Brian Greene from New York said, it takes imagination to see a hidden connection between two things that are apparently separate. And so it's such an interesting conversation to start. And the conversation was inspired by the title I was given by Perimeter. And yet the scientists were fascinated by it. They all said, that's such an interesting thought. And it made them think about what imagination means to them as a scientist. And then the second part of the talk was about using narrative to explain abstract concepts to young children, which is what I do. I'm a children's author. I'm not a scientist. I'm a writer. And I work with scientists to try and write adventure stories that provide a vehicle to explain scientific concepts to young children.
Let me follow up on there then. How young can a child be before that imagination starts firing as it relates to science?
I'm always asked very specific questions about ages of children, and my experience is that you cannot generalize. There's such a spectrum of ability, of interest, and some children latch onto things very, very early. We had a child came today and asked the most extraordinary question about wormholes that we had to get a professional scientist to come and answer, and he can't have been older than 6. And yet other people will come to things later in their life. One of the reasons my father and I started writing this series of books was to give people of any age an entry point into these subjects, because some people may not have had the kind of education at an early age that would equip them to approach theoretical physics as an interesting subject now. So I've had 8-year-olds tell me that they've enjoyed the books that are theoretically for 6 to 9-year-olds.
Before we get everybody else involved, let me do one more question, and that is, I'm sure everybody assumes that the daughter of Stephen Hawking is a whiz at math and science from the time you were a year old. True or false?
Actually, I was a very early reader. I actually slightly different pattern in that I learned to read at an unusually early age and became a prolific and obsessive reader. So my interest is very much in the storytelling, in the literary area, and what's been really nice for me is the way that that has allowed me to go on a journey into the kind of science that my father and his colleagues do and bring what I have to offer them as a storyteller to what the extraordinary and complex science that they have to offer to kids.
I'm reading between the lines here, and I think what you just said is you probably stunk at math.
That's right.
Yeah, that's okay.
I thought you were going to let me get away with that.
No, I think
thought if I keep talking for long enough, I'll use up my allotted time.
Was just a hunch. Was just a hunch what you just confirmed. Thank you very much.
My answer was good.
Before we get everybody else in, let's do one more thing here. We want to check out a clip from a Toronto math teacher on some of what we've been talking about. So Shelton, if you would, Mr. Director, please, roll tape.
I had students here, they tell me that in elementary school, believe it or not, one teacher's in their class and they tell them, I didn't like it math, don't worry about it. You don't go in a class and tell the students, I don't like math, and you teach them math. Myself, that's what I want to do for a living. To become a teacher, a math teacher. Now these days, I will tell you this, the failure doctors become teachers, and they hate this. They hate the teaching. They're only there because they didn't get to med school. And then the poor kids pay for it. In grade 3 in Europe, they learn how to deal with mental math. They teach them, if you have to take from 40 out 12, first you go down 10 and then you go down 2. You don't try to figure out with your figures. If I have to go 8 plus 6, they tell them, go 8 plus 2 is 10, then plus 4 is 14. And these days now...
That's how we all learned it back in the day. Okay, Ian, your turn. What do you teach?
I teach math at the University of Waterloo here.
How many of your students have come to you at some point in your career and said, Professor, I don't do numbers?
Very few, because we're very blessed to have very, very strong students here.
How many have told your colleagues, we don't do numbers?
There are lots, unfortunately, of students out there who have math phobia, who've developed that along the way, and it's a difficult problem, I think, for us as a society, with mathematics and science underpinning so much of what goes on. And math is an interesting discipline that way, because there seems to be this perception that it's cool to be bad at math, right? That if you, as a math teacher, if I meet somebody and they ask what I do and I say, well, I teach math, they often will say, oh, I failed grade 10 math, or I was never any good at math, and they're very proud about doing that.
They're proud of that.
Yeah, but it's very different than, I imagine, not being an English teacher, than being an English teacher, I suspect. If I was an English teacher and I said, I'm an English teacher, very few people would tell you that they couldn't read, even if they couldn't read, potentially.
Well, tell me this, do you think it's important for anybody to have, let's say, this skill, to go into a restaurant, to get the bill, and just off the top of your head, without writing it down or using a calculator, figuring out what a 15 or 20% tip would amount to?
I think number skills, numeracy are very important. I think that mathematics is again a balance. Arithmetic is a part of mathematics and being able to do those kinds of calculations. Some of us are blessed to be very, very good at that, and some of us, for whatever reason, haven't had the practice or never developed an aptitude for it. But mathematics is also about, as all the sciences are about very large picture ideas too. And trying to develop that balance is such a difficult problem for teachers to try to tackle, that I believe that you need to have numeracy and number skills at the foundation to be able to then understand and do the higher level kinds of thinking and kinds of problem solving, and the imagination to be able to connect different ideas together. You need to have the tools in your toolkit to be able to build that structure.
A follow-up to Sanjay. Tell me why it's still important nowadays to know off the top of your head what 7 times 7 is without using a calculator or a smartphone. Why do you need to know that?
Because using your calculator to do everything, just like driving everywhere will atrophy your muscles, using your calculator will atrophy your mind. And you won't actually understand the number system. And for the restaurant bill, that's usually not a problem. There's a tip table you can use. But where it becomes a problem is as a citizen of a democratic society. We have to understand when we see the government budget, what fraction of our spending is going to education, what fraction is going to health, what fraction is going to bombing other countries. These are all parts of the budget you want to see and feel at a glance in your brainstem.
But just as when we do programs in the past on literacy, and some people say to this day, there are some basic facts you've got to know about society in order to be a participating, contributing member to it, but others say, no you don't, Google's got everything you need. One click away. You just don't have to have that foundation anymore. Can you not make the same analogy for math?
Well, for 7 times 7, yeah, I don't think it's essential for every citizen to instantly remember that it's 49. But they should roughly know that it's 50.
They should roughly know that it's 50 because they have to have some understanding of the
feel for the numbers and scale. That they have to know that it's not 500, that it's not 200, that if you work at $7 an hour and you work for 7 hours, you're not going to make $7,000. And if people just shut down and say, well, it's numbers, I don't do numbers, I'm sorry, then they're going to be easy marks for the people who do numbers.
You don't hear that at your school, do you? Sorry, I want to be an engineer, but I don't do numbers.
What they say instead is, I do numbers through name your favorite engine on the internet, Wolfram Alpha, or they've outsourced their brain to calculating engines. And that's as effective as outsourcing all your manufacturing. It'll destroy your society.
That's applause. Okay. We mentioned last night, I think a lot of people in this room probably know Sir Ken Robinson, who has been, I guess, a star of YouTube in some respects, those lectures that he gives. And we played a clip last night from somebody else who is starting to get that kind of a reputation, Sugata Mitra. And we want to play a little tape from him right now, and then we'll come back and chat. Roll tape, please.
What if I were to say that arithmetic, as we teach it today, is an obsolete skill? Okay? The whole world will erupt if I say that, because they will say, reading, writing, arithmetic. That's the core of whose education? Core of the military education. Go back 200 to 300 years in this country and say that, 300 years later, no one's going to teach anybody how to shoot a gun, and no one's going to teach anybody how to ride a horse, and the teacher's going to say, but, those are basic life skills. This guy will get killed when he moves out. And you have to say, no, ma'am, the world will have changed. These things will become sport. Shooting is a sport. Horse riding is a sport. Will arithmetic be a sport in 2061?
Arithmetic as a sport. Interesting. Neil, let me get you in now. We're trying to understand what makes somebody scientifically literate. Would you include basic arithmetic skills on that list?
Yeah, I think it's a foundation for scientific understanding of the world. In many ways, the most successful sciences are those which translate properties of the world in mathematical terms, because that is our most precise way of understanding the world.
Is it possible, in your experience, to be passionate and great at science, but lousy at math?
Yes, I think it's possible to be passionate. I mean, there are many things you can love doing. I think a marine biologist, who enjoys the animals in the sea, and filming and photography. Of course, many of these aspects are vital to being a scientist, loving the natural world. But I think at the end of the day, the quantitative aspect of science is one of its most powerful features.
Because I wonder if those skills go hand in hand. If you're great at science, you're automatically going to be great at math.
No, I don't think so. No, I think it takes all sorts.
It takes all sorts.
Science takes all sorts, and I think one of the things probably all of us agree on is that we'd love kids to enjoy science in whatever way they participate, in it. And one of those ways is doing experiments for themselves, and a computer is not a substitute for actually building something or doing something or playing with something for yourself. So I think this focus on numbers and especially on computer literacy is missing a core element, a core ingredient of science.
Andy, I saw you shaking your head when I asked if you're great at science, are you automatically great at math? You don't think so either?
No, well, I'm not a great scientist, but I'm not great at, I don't feel that my maths is good enough. I mean, I'm quite numerate, but I have a bit of maths anxiety, I think, which is something that a lot of students feel at school. But I have to do statistics and so on for my job when I'm thinking about research, and I'm trying to work out if there are correlations and so on. So I do need that, and I need skills to do that. And sort of basic arithmetic, it's really important to have in your head to be able to do things. I think, the typical bill at the bar or whatever it is you're trying to do, I think that's it's good for you to be able to manipulate numbers, to think about numbers, and just top things up. It's sometimes quicker than finding your calculator on your phone anyway. By the time you've done all that, you might as well have done that. So I think that it's all about this asking questions and being able to think. As a scientist, that's what you've got. It's the asking the question, the right question, and investigating that. It's and then using tools to do that. So at least I know what type of statistical tests there are. I couldn't tell you how to do them immediately, but I know the different types that I could use for particular things. And I think that different people, you need to know what the resource base is to ask questions and answer them. So the basic maths, I think, is something you need in your repertoire.
Let me follow up on the teacher angle, though, because we've, over the course of this series, interviewed lots of students as well who have said, when I take science or when I take math, it's not my strongest subject, and I often feel as if the teacher makes me feel incompetent in the way that he or she teaches it. Do you hear that? You're nodding your head. Make me think that you have heard that.
I've heard it, but I'd like to. I train teachers. I have teachers who teachers that come in to want to be teachers. That isn't the phrase I want, is it? But people who want to be teachers, I train them to become science teachers in the UK, and so they're very passionate about science. They've often come from a scientific background, either straight out of university or have done jobs in science, and now wanting to share that and pass that on to students. But I think it's about the first week we spend talking about awe and wonder of science and reigniting that childhood wonder of the world. So we look at, I get them getting pennies and predicting how many drops of water they can put on a penny, and it's far more than you'd ever expect because you get that lovely. And so you start, but that sort of the extraordinary and the ordinary, start to get that wonder of what's happening and seeing it through a child's eyes again. I think it's really important. You do lose that, and every kid does have asked questions. Every child, you see experimenting, the youngest ones, what does this taste like? What does it feel like? It's a natural part of being a human, and then it becomes more quantitative as life goes on, when you want to be more objective about the world and understand the world in a different way.
Let's drill down on this some more. Go ahead, Neil.
No, I just wanted to say that the questions you're asking are dealing with now, but the pace of change is so rapid with technology and the technologies which are coming. So if you think about digital technologies, for example, as a tool, or if you think about just numeracy as what students need now to cope with what they may have to do in the workplace now, you're missing the big picture, which is the world is changing so fast. We don't really know what's coming. There may be things coming like quantum computers, which can handle data on a vastly greater scale, and will be very, very important for all aspects of society, for health, for education, for industry.
And therefore what?
Pardon?
And therefore what?
Well, therefore, the kids of today need to be taught the skills that enable them to think for themselves and to handle the unpredictable, which is what's coming.
That means, I think, Ian, that we need to have teachers who are not only passionate about teaching math and science, but know how to do it for those for whom numbers is not my thing. In your experience, do we have those teachers today?
We do. We're very blessed to have really fantastic teachers in this province, in this country, and I'm sure in places like the UK and the US as well. I think one of the most important things in the work that we do in terms of working with teachers is helping teachers themselves improve their mathematics skills, to learn some more math along the way. That will help them, I think, become better math teachers. Teachers are so busy doing so many different things, trying to be everything to all of the students in their class, having a huge spectrum of kids in front of them at any given moment, and trying to help them have the tools in their toolbox to be able to do what they need to do, to be able to understand the math beyond what they're teaching or the science beyond what they're teaching, to be able to give that better perspective, I think is really, really important.
Lucy? Sanjay, go ahead.
One thing I'm always impressed with when I come to Canada is how polite everyone is, and how unwilling people are to say anything bad. And it's a skill I definitely could use some development in. So I'm going to say I think there's a serious problem with math teaching in my country. And what Andy talked about math anxiety, and you mentioned it too. Math anxiety is a result of math teaching. But what students think is they think it's something inherent in them, that is their fault. And so that is just Stockholm syndrome, where the captors have identified, the captives have identified with the captors. And really it's the fault of the teaching. And it's, in particular, it's the idea that there's only one way to get the answer. And so what happens to the students when they're taught, okay, here's your problem, and here's the algorithm you memorize to get the answer, you think of yourself on this high mountain pass, and this thin, narrow pass that you have to go through, and if you make one misstep, you fall into the valley of error below to your death. With that kind of image of what's happening, you're going to be terrified. And if you do that day after day after day, and math is the subject that's required every year of school, so you have a lot of time to drill that damage into people, they're going to be hosed for the rest of their life. So it's a miracle we don't produce more math anxiety.
Okay. Lucy, you wanted to add?
Well, I just really enjoy the highly evocative way that you speak. I think it's brilliant. One of the things we've been trying to do with these books is to remove the fear of science at an early age, to be very inclusive, to be very entertaining, to be very accessible, and to say, you can understand this. You know, we sort of take you by the hand and walk you through these things. And the idea is that if you've understood this, then the next step would be to go and understand something else, but because you've taken the fear and the phobia away, it would be enjoyable.
I wonder, though, how much of this phobia that the students receive from the teachers happens, Neil, because, not like your colleague sitting to your right, you know, people obviously in the post-secondary world have their PhDs, they're experts at it, they know how to do it, but there are plenty of elementary and secondary school teachers who are also afraid of math, and that's got to come through when they teach it. Am I right about that?
Absolutely. I think the pace of change in society has left teachers unqualified often to deal with the latest things where the kids can know more than the teacher quite frequently. So I think one of the things we've discussed at the summit going on at Perimeter is in what way will education be transformed leading up to 2030? And just, one of the ideas floating around, just to give an example, we all have a smartphone, or most of the society has a smartphone now. It's very likely that each kid will be carrying around with them a personal teacher which will be an electronic device which can keep track of their own progress and can offer them guidance, what they should be reading, what they couldn't be reading, can offer them assessment. This is very, very likely that this will become possible. So one should view this as an assistance to the teacher, to the classroom teacher, that kids will have their ability for their own educational program to be tailored to what they're good at, what they love, what they want to do. And we need to start anticipating these changes and not imagine that the school system is rigidly fixed the way it is now. It was invented in a particular time era,
Yes.
which was the start of the Industrial Revolution, or just before it, and the Enlightenment, and the world has changed. And there are far greater demands, and there are also far greater opportunities for educating kids.
So let me talk about educating teachers. Andy, how can we make elementary and secondary teachers who may not be specialists in math or science themselves feel more comfortable about it so that they can teach kids not to be afraid of math and science?
Well, you've hit it on the head with not being qualified in the science, because we have a huge problem getting enough teachers who have got a background in science or in maths into the classrooms. And there's the UK has got a big program to try and get more physics teachers into physics graduates into the classrooms, but we've still got a huge gap. So that's a big issue in terms of how to get people that have got mathematics background but not in a conventional straight through or physics in the conventional way. We have things called enhancement programs that people do before they go even into the teaching, the learning to teach. They spend 6 months or a year doing the maths again, or doing the physics again, and with teachers, just the ones you're talking about, the ones who can think about number in a different way, think about maths or science in a different way, that is more problem solving, more about the skills of looking at a problem and thinking what different ways working together, that collaborative thing, rather than that step-by-step process, which is a much more authentic approach to the real world. We don't ever just think, well, if you do just think there's one problem, then you don't get very far. You have to be solution focused and think, well, what do I need to do next to achieve?
Right. Let me do a minor timeout here because I want to do some business with the folks at home for a second. We're about halfway through our program this evening. A good time to remind everybody that we are tonight live, as we are all week long, at the Perimeter Institute for Theoretical Physics, Lazaridesville, they call it, I understand, here in Waterloo, Ontario. If you can't join us in person, you can still participate in tonight's broadcast. We are streaming live and live chatting right now on our special website, tvo.org/learning2030. You can join in via Twitter. There are a couple of hashtags you can use, hashtag learning2030 or hashtag EQX13, EQX for the Equinox Summit that you're at. And you're looking at a shot right now of some of the tweets that are being shown on the big screen just above us here at the Perimeter Institute. Okay, let me ask this audience, everybody here know what Pisa scores are? It's got nothing to do with the Leaning Tower in Italy. You know what Pisa scores are? This is the Program for International Student Assessment, Pisa. And some people think these are a very big deal. And we're going to share some numbers with you and our television audience right now on how Canada is faring. Let's bring up this graphic if we can. Turkey, for example, the math and science average for their Pisa scores is about 450. The United States, a little higher, almost 500. France, also in the same ballpark, around 500. Switzerland, north of 500. The UK, right around 500. Canada, well north of 500. And Finland, we've been hearing all week long how the Finns are fabulous at everything in education. They are very strong, almost at 550. The OECD average, incidentally, is just a little lower than 500, so Canada is well above that average. I know in the province of Ontario, we have had some pretty strong scores in this department as well, and various governments have blown the trumpets to say how fabulously we're doing as a result. My question is, and Sanjoy, let's start with you, what value do you attach to these kinds of scores?
Absolutely zero.
Zero.
So I've taught at Cambridge University in England and MIT and now Olin College. So I've taught students who've on the Pisa scores would be well above the average. And what I find is that their ability to reason mathematically is very, very low. What they are fantastic at is they have a lot of armor plating. So you show them a problem, and they've seen a vast library of problems. They can solve it quicker. So the students I had in Cambridge, they could solve many exam problems that I couldn't, and I was supposed to mark the exam, because they had so much practice at solving problems. But if you change the problem ever so slightly, then it was hopeless. Then they didn't have a memorized repertoire anymore. So I pay no attention to the Pisa scores. What I want to know is, do you deeply understand the concepts?
Neil, you and I have both, I'm sure, spoken to ministers of education in this province who say our PISA scores are great and therefore we're fabulous. No, and he says it doesn't mean a thing.
No, that's not what they say to me.
What do they say to you?
They say to me, quite frankly, that we realize tidal wave is coming, and we don't have the policies or strategies in place to deal with it. Everyone knows this in education.
What's the tidal wave you're referring to?
The tidal wave is the internet, online teaching, the greater demands on the kids when they graduate. That if they're going to be successful in life, they need to be much quicker on their feet. They need to deal with all kinds of complicated situations, which people didn't have to before. So they know the demands are greater than ever.
And the PISA scores don't reflect that?
No. I mean, I think there is a common awareness that the standards within schools are dropping. And you can always recalibrate your scores to make it look like it's rising, but actually it's dropping. I mean, I taught in Cambridge as well, and I could compare the exam papers done in the 1960s by students with the ones being done today, and there is no comparison. The standards have declined dramatically.
Which Cambridge are you talking about?
England.
You mean Cambridge, England? Okay.
Cambridge,
because he
England.
lives in Cambridge, Massachusetts,
But
which is
I was talking about Cambridge, England.
And you were talking Cambridge, England. Okay.
So, so you know, it's a consequence of partly of the massification of education. We have this idea that everyone in society must go through exactly the same system and get qualifications, and we've turned our schools and universities into factories.
Let's hear from Ian and then Andy on this as well.
At the same time, though, if you look at the very brightest high school students out there in mathematics and compare where they are now to where the brightest students were 10 years ago or 20 years ago when I was in high school, there's no comparison whatsoever. The students are so much more advanced now than they were when I was in high school in the early 90s. If you compare to what I was a good math student, I did very well nationally on competitions. If you compare what students can do now, so much more than what we could do then.
Andy.
Yeah, I disagree about standards going down completely. I think I see some of the best teaching that in schools that I visit and I work with, and I think the standards. It depends what you're trying to talk about, and this idea that, I mean, just as you're saying, you know, the time now compared to before, the brightest kids are doing very well. There are bigger gaps in lots of places, and there is a big issue about the gap between the best, well, the highest performing student, because that's not necessarily the best, and the lowest performing student in the system in which we are in. Then there are areas that are increasing gaps, but I really think that the way teaching has changed and how it's much more individually focused and so on. In the UK, I see lots and lots of examples of that where children are supported, students are supported in through these things. There are still things like maths anxiety, there are still things where the students are disaffected with the system, but it's often some of it's to do with the school system, some of it's to do with the outside system, the context and so on. And I find it's very demoralizing for teachers to hear that it's getting worse and worse, because actually teachers are getting better and better from what I can see. They are progressing in their skills. There's a hunger to be better all the time. And governments can easily change scores to reflect, we want to change something. You know, schools will, they'll use the data the way they want to show that things are going down or going up. If it goes down the year, it's the teacher's fault. If it goes up, it's the government's policies.
Lucy, do you want to weigh in?
Yeah.
Well, I come at this from a slightly different angle because
Sure.
I'm not formally involved in education as the other people on this panel are. But I visit a huge number of elementary schools in the United Kingdom and in all sorts of countries, and the sheer enthusiasm and the energy of the kids for science, for scientific information, what they already know is phenomenal. And in a sense, what you're needing to do is find a way to teach them how to use that information, how to apply critical thinking, because they have the information, it's coming at them on the internet. So I really agree with what Neil's saying about changing education to reflect this extraordinary social change that we're living through. But just an anecdotal thing. I grew up in a physics household full of physicists.
You don't say.
Yes. I've been able to monitor the cool barometer of physics from a very close vantage point all my life. So when I was a child and people say, what does your father do? And I go, he's a cosmologist. And people are like, he's a what? Or he's a scientist. And people go, people thought that was really deeply uncool. But now I notice that the barometer has changed. And although there is a lot of gloom about the way children engage with science, science is increasingly becoming cool, being clever is cool. And I think we're going to get to a point, so just like Ian's point about reading, 20, 30, whatever period of time in the future, there will be a point where you cannot say, I'm not interested in science, science has nothing to teach me, I could engage with science, but I choose not to. Because it would be like saying now, well, I could learn to read if I wanted, but I don't think reading has anything to teach me, so I'm not going to bother.
It'll be considered as essential as
I think so.
everything else.
I really
Neil,
believe
you
that.
look like you wanted one more word on this.
Yeah, I wanted to say in response, I mean, I understand as a person who teaches teachers, you feel an obligation to pump up the system. And
That sounded like a shot. That sounded like a shot. Okay.
I don't want to talk teachers down by any means. I mean, teachers are wonderful people often with incredibly pure, goals in life, and they really want to help kids, and it's one of the most important professions we have. But I think, if we look at things, with a cold eye, in Britain at physics A level, which is the end of secondary school, they removed calculus from the curriculum. There is no calculus anymore in physics A level, which is quite shocking.
You think that's a mistake, obviously.
Well, it's to a physicist, this is insane. I mean, Newton discovered one equation that describes an infinite variety of phenomena.
Why did they drop it?
They dropped it because they considered it would put people off, and they wanted more people to take physics. That's right. So they said, okay, cut out the calculus. People find that hard. Now, I'll give you another example, and this is here in Waterloo, that when you learn Newton's equation, this one equation describes an infinite variety of phenomena, all motion, forces, the way things move in the world. It's beautiful, it's stunning, it's worth spending years just understanding what that one equation, F equals ma, what does it really mean? You could spend years analyzing it, and you should. And what they do instead is they work out 10 different consequences of that equation, which are various formulae relating S to U and A and T and D, and then the students memorize the 10 formula into which they can plug numbers and obtain answers to specific problems. That's absolutely not what you should be doing. You need to learn the one equation from which, if you understood it, you could derive everything. And that concept has, the dumbing down of physics and math teaching is a tragedy.
I'm hearing... Sandra, go ahead.
I completely agree with what Neil said. One of my early projects when I moved to England was I went to the education library at the university, and I looked up all of the old exam papers, not for the university exams, but for the high school and the secondary school math and physics exams. So the 13-year-old papers, exam papers, were harder than the papers we set for the first-year university students. And if we set, this was the Nuffield Physics O-level, and if we set those 13-year-old exam papers to our first-year students, they would have failed. And so this was the 1960s exam papers for the 13-year-olds compared to the 19-year-olds at the University of Cambridge.
So our standards have gone down.
The standards unquestionably have dropped into the toilet. And what the cause is, I don't blame the teachers, but a whole bunch of enthusiasm can't solve this, can't actually paper over this fundamental problem.
Well, let me read a quote here, and we're going to bring it up on the screen. We'll share it with everybody here in the room, that may speak to some of what we've just been talking about for the last few minutes. This was in the New York Times very recently. Think of it this way. You can appreciate art without acquiring the ability to paint, or enjoy a symphony without being able to read music. Math also deserves to be enjoyed for its own sake, without being constantly subjected to the question, when will I use this? Sadly, few avenues exist in our society to expose us to mathematical beauty. In schools, as I've heard several teachers lament, the opportunity to immerse students in interesting mathematical ideas is usually jettisoned to make more time for testing and arithmetic drills. Lucy, is it important for our schools to teach math just because it's a beautiful thing?
It's not a question I can answer.
Who shall we pass it to? Andy, what do you think?
I mean, I agree entirely, and I think the things that we've been talking about over this week with the future school, we're considering this as is about thinking things holistically, higher order thinking skills, and so on, are the things that we should be focusing on, and I really do believe that, and I've got no question about it. I think the problems in the system which you're talking about, you know, that whole decision of whether you should take out something out of an exam, the whole problem is our whole system is run by exams. So teachers teach to exams because they're under pressure to do that. Right. I think that if you remove exams from the system in that way, then teachers would be free to teach the things that they really value and the things that they believe in are important, that would have more time for doing that sort of thing. And I think that would be the way forward. I think that the teachers are doing the best what they can do in the limited time they have, but
Ian,
that's the problem.
Teach math just because it's beautiful?
I think there needs to be some of that, but at the same time, math is a combination of hard skills and soft skills, of learning to do computations, of learning to do important basic skills, and at the same time being able to appreciate these bigger picture ideas. And we need to try to find a balance in that. We seem to have gone from a system where some number of decades ago we were very focused on hard skills. And now in our system in Ontario, we focus very much on problem solving and discovery, which are very important concepts, I think a little bit at the expense of those hard skills of being able to factor a polynomial equation and being able to do calculations. And somewhere in the middle, there's a happy medium. And we need, as a society, to invest more somehow in helping teachers figure out how to do that better.
Sanjoy, let me follow up with you on this. It doesn't take much explanation for somebody to look at a painting and say, that's beautiful and I know why. Or to hear Beethoven's Ninth and say, that's beautiful and I know why. Can you help us understand how when you look at a mathematical something, an equation or whatever, you see beauty that perhaps the rest of us don't, and we want to understand what that beauty is?
I have an alternative answer. So, which is, I think math is so useful, we don't even need to show it's beautiful. I think it's beautiful, and if we can convey that to students and they appreciate that, that's fantastic. But there's another kind of beauty in it, which is that it underpins not just the physical world, but so much of our social world. And you can't understand the social world without it. So the only time that I helped somebody cheat in school actually relates to this. So I helped somebody cheat in 9th grade in history class.
Okay.
We had a geography test, and we had to list all, for each country the teacher gave us, we had to say how far it was from the center of the universe, also known as the United States. And so all of a sudden the person next to me says, "Psst, how far away is Cuba from the United States? 1,000 miles? And I said, after a bit of moral doubts, I thought, no, 90. And so then everything was fine. The teacher said, well, everyone did well, except one student said Cuba was 90,000 miles from the United States. So this student has no conception of the size of the world. They're pre-Columbian times. And then, I thought about it a little more. I thought, that's halfway to the moon. But given what we learned about Cuba, maybe that's not so implausible. But so the mathematics there actually organizes a whole bunch of random facts. You can actually see what's close, what's near, what we have to worry about, not worry about, and everything else, everything turns into random junk without a mathematical organization. And that's what we could actually show students the value of mathematics in.
You know, I was going to ask you this next question, but then when we were talking before we went on the air, you confessed to me that despite the fact that you live 5 minutes from Fenway Park, you've never been to a baseball game in your life.
Oh, I didn't say that.
Okay, you don't care about baseball.
Right, and I didn't confess it. I was half proud of it. But other than that,
so
I
you
accept
do
the-
not get this next question
Fair
because
enough.
it does require a modicum of knowledge of baseball. So I'm going to Neil on this one.
He played cricket.
I'm not sure he knows much more about baseball than you do, but let's say, for example, we're about to embark on the baseball playoffs, so this is something people who love baseball will know. If you say the number 714, people who know baseball, anybody in this room know baseball? If I said 714, shout it out. What does it mean? Babe Ruth's home runs. How about that? That's fantastic. I'm proud of you guys. Well done. Yeah, Babe Ruth hit 714 home runs, and people who know baseball, you say the number, they know what it means. Do you think there's similar corresponding knowledge for science, whereby if I said to this audience 14 billion, they'd know what that meant?
I hope they would.
Try it.
14 billion.
Anybody?
There you go.
Age of the universe.
More
All right.
than Babe Ruth. That's because Waterloo.
That's right.
Selection bias.
Try it in New York. I'm not sure you'd get as many people. Explain that phenomenon. Why is that important?
Oh, I think it's crucial that people have a conception of our place in the universe. As Sandra was saying, it's if you're going to understand the world around you and be able to make rational decisions, you need to have a rough conception of its scale and where the countries fit together and so on. And I think likewise having a conception of the whole universe, which you can put into numerical terms or terms of scale, gives you a picture not of where we've come from, the Big Bang, and the fact that, there's been an evolution of the universe and a huge amount of change, obviously, since the Big Bang. And it also gives you a picture of where it's going and the world of opportunity which is ahead of us. So if you know that, the Higgs boson was discovered last year, and you might say, well, so what? It's some obscure particle in a laboratory, But if you realize that actually space is full of this stuff, and it carries energy, and one of the implications of the Higgs boson discovery is that we may not be, it seems we are not, in the lowest energy vacuum. There's another one. And so the universe is going to undergo a very dramatic evolution in the future. It changes the picture of what the world is. It's a very dynamic place. There are all kinds of things going on in it. People picture the world made of atoms. This is what we learn in school, is that it's a kind of Lego model of the world. You build up molecules and then materials, and it's probably the way most people picture the world.
Okay, so 14 billion is one fact.
This is not the real world. The real world is quantum. It's way more interesting than that. And this more interesting stuff is around the corner. We're going to have quantum materials, quantum electronics, which will make the digital revolution look like nothing. And this is what's coming. That's why and the key to it all is math. The only way we've understood the quantum world is through mathematics.
Well, I need some more things on the list. Lucy, for example, in that baseball world, 714, people know. In your world, in the science world, for example, 14 billion. What else is on the list? You've got facts.
In numerical terms?
Yeah, those kinds of
in terms of great discoveries that have changed the way we view the world.
You're putting this kind of information, I suspect, in your books that you've got young people reading.
We're talking today about imagination and 3 great discoveries that came specifically out of Cambridge, my hometown, and we were talking about gravity, evolution, DNA. 3 incredible scientific discoveries that are actually so familiar to us all now that we all sort of feel like we intuitively understand them. But those were discoveries that were made by scientists using imagination plus information and intuition, resting on mathematics. So this is important stuff. This is how we understand the world around us. And this is how we hope to make progress into the future. We will continue to make discoveries that will unlock the universe to us, as well as having a profound impact on life on Earth.
Andy, what else is on the list?
Well, I'm thinking this comes right to what I believe what scientific literacy is about. It's not about being a scientist necessarily. It's about having an appreciation for what science has on offer. So it's part of being a global citizen now, part of being part of the world and understanding. You need to have, at least know what DNA is, know that it's part of you, know that there's something, I've heard of those things. So it's the idea of a core curriculum, which is the sort of thing that is debated, and what's in, what's out, is a very hard thing to decide, because I definitely have photosynthesis and stuff in there, because that's my passion. But the next teacher's passion is quantum mechanics or whatever it is. So how do you decide what are the fundamentals that every citizen has a right, every child has a right to know about the world? Because we know this. Children should know that Higgs bosons exist. They should be aware that there's a particle accelerator, the biggest experiment on the Earth going on, and we're discovering things, that we're asking questions about the world.
Ian, what's on your list?
3.14.
3.14. I assume you mean pi?
Pi, yes.
Okay.
But I think this idea of literacy from a reading point of view versus numeracy, and this whole discussion ties up in some sense. If you said to be or not to be to everybody,
right,
they would say Shakespeare. But 14 billion doesn't resonate as much, and so that's part of what we as scientists and mathematicians and educators need to do to try to get more scientific literacy out there, try to get people just tuned in just a little bit more, even if they're not practicing scientists or practicing mathematicians.
Part of the regular conversation.
Yeah.
Part of that foundation of stuff you know.
And that it is cool to know these things, and it's important.
Sanjoy, what's on your list?
10 kilowatts.
10 kilowatts?
Yeah.
What's that a reference to?
How much energy each person in North America how much power each person in North America uses. And
over what period of time?
Every second we use 10 kilojoules. So that's 10 kilowatts. So it's 100 light bulbs. So we're each controlling 100 light bulbs of energy. And that's where our standard of living comes from. And I would want everyone to have an appreciation of that, because our energy usage is going to have to change. And we have to plan, okay, suppose we only have 20 light bulbs worth of energy. Where would we spend them? And that's the kind of planning that people have to have an appreciation of some physics, mathematical scales, so they can be citizens of a democratic society and not have it planned for them.
Lucy, I've got about a minute left here, and you've got a new book coming out called George and the Unbreakable Code.
Indeed.
What's that a reference to?
Well, I can't really give too much away, but I think that perhaps I don't have my core audience here, seeing as my core audience is average age around 7. It's an adventure which takes us into the world of quantum computing.
Quantum computing. And the unbreakable, are you allowed to say what the unbreakable code is, or does
no,
that give it away?
You won't read the book if I tell you what it is.
Okay.
Don't break the code.
We do not want to give that away. Okay, understood. Friends, that's our time. I want to thank everybody for participating in tonight's discussion, starting with Ian Vandenberg, the Director of the Center for Education in Mathematics and Computing at the University of Waterloo. Neil Turek, the Director of this Perimeter Institute and the author most recently of The Universe Within, From Quantum to Cosmos. Lucy Hawking, co-author with her father Stephen of George and the Big Bang. Sanjoy Mahajan, Associate Professor of Applied Science and Engineering at Olin College in Needham, Massachusetts, very close to Fenway Park, and he's never been. A sin. And finally, Andy Chandler Grevitt, Teaching and Research Fellow at the University of Sussex School of Education, East Sussex, England. Thank you all very much for participating. It's been great to have you on tonight.
Support Ontario's public television. Donate at tvo.org.